Hi there, YouTube. In this video, we will start implementing our convolutional layer. As you saw in the previous video, we will have about 4 methods in our layer, and we will have different parameters that we will use to set up our layer and that we will store for future use. Before we start, I'll create a config file which will hold reusable types and type definitions that will be used throughout this process. It will be eigen-based data structures, and since they are hard to type out every time, I choose to make these types globally available whenever the config is included. The primary data will be doubles, but you could use float if you don't care about the precision that doubles give. I'm gonna create a dynamic matrix which we will use. And after that, a column vector. After that, I'm going to create a namespace, and within that namespace, I'm going to declare a struct that is going to hold size information. I was about to create it with unsigned ints, but I decided that I would rather have ints so that I can invalidate the sizes if I need to. So this is the basic configuration that will be used in several layers. Now I'm gonna create a new class, which will be our convolutional layer. I'm just gonna move the files into a source folder, and we're gonna declare a default constructor. And second, we're gonna declare a constructor with parameters. First, I have to include our config file. We're gonna take in size of the input size, a input depth, a kernel size, and just for ease of reading the class, I'm gonna declare the type internally called size. I'm gonna put in a layer depth, which is the amount of kernels, and I'm gonna make a pointer to a vector of vectors of matrices, which will be our actual kernels. Next, I'm gonna add a pointer to a vector of biases. I'm just gonna make it more readable. And we're gonna do an initialization method that takes the same parameters. Our constructor will basically be calling the initialization method so that every member variable gets properly initialized. This setup allows us to create empty objects with uninitialized member variables and initialize them later. I'm just gonna create the definitions of the layers, and I forgot the namespace. This actually makes the type def not needed, but yeah, I'm just gonna keep it for now. I also need to include vectors from the standard library. Now I'm gonna define the actual methods. But before that, I'm gonna declare some member variables. First, we will declare the input size and initialize it as 00. Whoops, wrong place. Next, we will store the input depth and also initialize it as 0. And then we will store the kernel sizes. Whoops, I've made a mistake. And also initialize them as 0. Then I'm going to store the layer depth, which is the amount of kernels. Also initialize it as 0. Then I'm going to store the pointers for the kernels. And initialize it as a null pointer. The same goes for the biases. I'm just going to copy these as we're going to initialize them in the initialization method. I'm just going to copy in from the method and store them in our member variables. Alright, that is that for initialization. I'm just going to make sure that our explicit constructor calls the initialization method right after construction. Next, we're going to set up our data. I'm going to clear out the kernels and the biases, since they should be clean when we first initialize the layer. I'm going to store the input data for later use. During backpropagation, this is needed, so I will create a data structure that holds this information, and I'll reserve space for it so that we don't have to resize the vector too many times. The depth of the vector will of course be our input depth. I'm also going to store the output size and initialize it as 0. In this version of the convolutional layer, our output size is the same as the input size. We will do a so-called convolution, or rather actually a cross-correlation, which uses the same method. There are 3 methods: same, full, and valid, which I'll explain as we implement the actual method. I'm just gonna leave a comment here so that we always remember that this is a particular instance of a convolutional layer. Next, I'm gonna make sure that we also reserve space for our kernels if they're empty, which they should be. This is also to prevent vector reshaping happening too often. And the depth of this vector is our layer depth, which is also another word for the amount of kernels. I'm going to do the same with the biases. And remember, for each kernel, there's also an actual bias. Also, I might have made a mistake. If we get a null pointer, this is gonna crash. So this is probably the more safe way to do it. Now we're gonna set up our actual biases and kernels. We're just gonna make sure that both of them are not set to anything. This also allows us to pre-initialize our kernels and biases so that they don't get reset. I'm gonna make a for loop. And actually I prefer k for each kernel, since layer depth represents kernels. And for each kernel we're gonna make a bias. Biases should always be initialized as 0. This matrix will have the size of the output size rows and columns, and will have the depth of the amount of kernels. Now we're going to set up the subkernels, which is going to correspond to our input depth. Which is why I'm going to use I. And kernels should be initialized as random numbers, but to prevent overflow, they should be normalized. You could initialize kernels as numbers from different distributions, for example, normal distributions. But yeah, I'm just going to use the internal random method of the eigen library. I'm going to construct the matrix in place and move it into our kernel vector. That is it for setup. We're actually done with the constructor and initializing and the initialization method. I'm just going to add some comments. That is it for the first video. In the next video, we're going to implement the actual calculation and the cross-correlate method and do a bit more theory about how to implement different versions of it. I will not be going into the math since there are sources that are way better at illustrating and explaining the math, and you would be better suited to watch some of those videos if you really need to understand the math behind it. Finally, I'm gonna do a bit of debugging just to make sure that everything compiles. If you found any of this helpful, feel free to like, comment, subscribe, or even make a donation. I'll be seeing you in the next one. Bye bye.